In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work.
So for example 1, for using conditional probability, you're assuming that one number from 1 to 7 is equally likely to be selected at random. Each number corresponds to one of the 7 figures shown. Determine each probability listed below, round to 4 decimal places if needed. And so this symbol that you see right here, this vertical bar again, means it means given that. So basically you're given it's giving a condition that has to be upheld first for the second one to can happen. And so the first one says the probability of getting a circle given that an odd number was selected. And so basically you're only looking at odd numbers. 1, 3, 5, and 7. What's the probability of getting a circle? Well, you have 2 out of those 4 possibilities. Oh, 3, sorry, there's 3 circles there. And so that's 0.75. The probability of getting a triangle given that a number greater than or equal to 5 is selected. And so if a number greater than or equal to 5 is selected, you're only looking at these cases here. So what's the probability of getting a triangle? Well, it's a 1 out of 3, or 0.3 repeating, 0.3333. The probability of getting an odd number given that a circle is selected. So here's all the circles. The probability of an odd number, you have 2 out of the 3. Or no, sorry, 3 out of 3. My brain wasn't working there for a second. 1, 5, and 7 are all odd, so that's a probability of 1. The probability of a number greater than or equal to 5, given that a triangle is selected. So I'm only looking at the triangles. A number greater than or equal to 5. Well, 6 is greater than or equal to 5. 2 is not, so there's a 1 out of 2 chance, which is 0.5. The probability of a circle or square being chosen given that a number less than 4 is selected. So number less than 4, what's the probability of a circle or a square? Well, you have one circle, one square. There's 2 that fit that description out of that 3. So it's a 2 out of 3, which is 0.6 repeating, or 0.6667 when rounded to 4 decimal places. And for the last one, the probability of a triangle given that an odd number is selected. So when I look at the odd numbers being selected, how many of these are triangles? Well, none of them are triangles. So it's a 0 out of 4 chance, which is 0. So given that is basically given a condition that has to be met before you start considering your probability. So example 2 for E-ZPass here. So you have this table here. People who use E-ZPass, cars and trucks, and those who do not use, and totals and whatnot. So if one of these vehicles is chosen at random, determine the following probabilities and round to 4 decimal places is needed. So the probability that a vehicle selected is a car. Well, when I look at cars, I mean, there's 2,461 drivers looked at on this survey. 1,462 are cars. So it's going to be 1,462 divided by 2,461, which is 0.5941. The probability that the vehicle selected used E-ZPass. Well, those who use E-ZPass, there's 843 of those out of 2,641, and that's going to be a 0.3425. Now, the probability that the vehicle selected used E-ZPass given that the vehicle selected was a car. So we're only looking at the cars at this point. So I'm not looking at the total number. I'm only looking at cars. So this is my new bottom number, the 1462. The vehicle selected was a car. So how many used E-ZPass? Well, 527 used E-ZPass. So it's 527 out of 1462. And that gives me a 0.3605. The probability the vehicle selected used E-ZPass, given that the vehicle selected was a truck. So I'm only going out of trucks now. There's 999 of those. And the 316 used E-ZPass. So it's a 316 out of 999, which is 0.3163. Now notice this one here. The vehicle selected is a car, given that the vehicle used E-ZPass. A lot of people think that this one here and this one here are the same thing. They're not. I'm given that this person used E-ZPass, so my total is 843. That's my bottom number. cars are 527 out of that. So it's 527 out of 843. It has the same numerator as this one, but the denominator is totally different. And it has a much higher probability as a result. It's 0.6251. So be careful that you understand what given that means, and don't confuse the opposite of that, because some students will do this calculation for this and this one for that. Make sure you know the given that is basically giving you the bottom number at that point. That's the best way to kind of go about doing it. Example 3, you're given that the probability of A is 0.4, the probability of B is 0.5, and the probability of A and B is 0.25. You're asked to determine the probabilities below. So what's the probability of A or B? Well, the probability of A or B, if you kind of go with things like if it's possible to have a probability of A and B both happening, when I do A or B, if I'm looking for that kind of category, kind of going back to the cards and things we did in a previous example, there is a possibility that you could count something twice. And that's why we want to make sure that when we use this formula, it's the probability of A plus the probability of B minus the probability of both A and B. So we can do this with Venn diagrams as well, but in general, using this formula, it's going to be 0.4 minus 0.5 minus 0.25, which is 0.65. The probability of A given B is going to be 0.25 out of 0.5, because that's going to be the probability of A and B over the probability of B, which is 0.5. The probability of B given A is going to be the probability of A and B again, 0.25, over the probability of A, 0.4, which is 0.625. So these are just using formulas. Based on the results from questions 1, are A and B independent? Yes or no? Being independent means that the probability of A and the probability of A given B would be the same thing, and the same thing with the probability of B and the probability of B given A. So you can see the probability of A is 0.4. The probability of A given that B is also occurring is 0.5. So there seems to be some sort of effect that B has on A, and likewise here. The probability of B alone is 0.5. The probability of B given that A occurred is 0.625. Again, there seems to be some kind of interdependence there. So as a result of that, no, they are not independent. In a very similar problem, you're given that the probability of A is 0.3, the probability of B is 0.6. The probability of A or B is 0.72. Determine the probabilities below. So the probability of A or B, again, using the same formula, except the only thing that's different now in this one is I know this one, and this one, and I'm looking for this one. So 0.72 equals 0.3 plus 0.6 minus the probability of A and B. And when I work this out, I get the probability of A and B is 0.18. The probability of A given B, I get 0.18 over 0.6 is 0.3. Again, that's the probability of A and B over the probability of B. This is going to be the probability of A and B over the probability of A. And you're asked the same question, are they independent? Well, down here, if you look, the probability of A and the probability of A given B is they're both 0.3. So B had no effect on A. And the same thing, the probability of B and the probability of B given A are both 0.6. So A had no effect on B. And because of that, because these are equal to each other, they are, in fact, independent. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.